Oh, all right, amigos, welcome back. My last video I cut off, I think, with two problems left to go on that same concept. But it's a good pickup spot if it's a day later or if it's the same day. Well, no big deal. But if it's a day later, you remember yesterday we were really looking at properties of isosceles triangles. And remembering that the angles opposite the equal sides are also equal. So in triangle A, B, C, AC and BC are equal. Our goal is to find the measure, however, of BCD. So when I'm doing this stuff, any of these problems, I'm not immediately going to the angle I'm trying to find. I'm finding any angle that I can easily. Does that make sense? Because then if I get enough information filled in, then it'll usually get me enough stuff where I can calculate the one I need. Right now, I don't know enough to do that. But this part here is key. So if I remember that those two are equal, then that angle and that angle must be equal. And if we have a 90 here, these two must add up to 90 and be equal. So then each of those is 45. Okay? Does that make sense? And even again, I like to have my measurements written in the triangle whenever possible. Okay. So now to get this part, I have a smaller triangle right here, this CDB triangle. And in this smaller triangle, I know I have a 90 here, a 45 there, and something here. Well, in a right triangle, I will do 90 minus this angle to get that angle. And there you go. That's how that guy works. Oops. I guess that's just covered up. Okay. Here's another one. Why don't you try this? And then I'll go through it with you. So pause me for 5 seconds and I'll go through it with you. Okay? All right. How'd this one treat you? It says in triangle ABC, the measure of BAC is 42. So we can see this guy right there is 42. And we know that ABC is 90. And then we know BD and BC are equal. Find the measure of CBD. I don't know how to find the measure of CBD because it's less than a right angle. Okay? But what I do know is that this guy here is 42. So I'm going to look at the bigger triangle because that's where I have information I can work with. In this pink triangle, I have an angle here that's 42. I have a right angle here. So that means 90 minus 42 will give me the 48 here. Okay. Now that I've got that, what I can do is I can look at this BDC triangle. Okay. And what you see here is that that line and that line segment rather are equal, which means that angle and that angle are equal. And that's going to be what? 48. And then I'm going to do 180 minus 48 and 48, and 48 and 48 is 96, and I should get 84. Woo! I mean, look at the math. The computation part's not crazy. It's figuring out what to compute, right? Let's keep on keeping on. Now we're going to move on to the next topic. Okay. We're going to show that the measures of all the angles in an equilateral triangle are equal, and each angle measures 60 degrees. Okay? And she says, I can also think of an equilateral triangle as an isosceles triangle. Basically, an equilateral triangle is a special isosceles in which all three sides are the same. Isosceles is two or more sides the same. Equilateral is all three. Kind of like the way a square is a rectangle square because it's got four right angles, or a square is a rhombus because it's got four equal sides, or a square is a parallelogram because it's got two sets of equal sides. So you can classify these things in multiple ways. So equilateral, special isosceles with all three sides equal. Okay. So if the angle x plus angle y plus angle z is 180 and they're all the same, 180 divided by 3 is 60. So each angle in an equilateral triangle measures 60 degrees. All right, so if every angle in an equilateral triangle is 60 degrees, which ones are equilateral triangles? Or as I like to do on our standardized test that we have to take every year about this time of year, which are not? All right, So all of a sudden, I see there's a 70 there. Nope. And I see a 90 there. No. Okay. Over here, I'm going to look at this one. If this angle is 60 and this angle is 60, and I do 180 minus 60 minus 60, that must also be 60. So the equilateral triangles are ABC. And then over here, the key is that isosceles trick. Okay. So this side is opposite that 60-degree angle. Well, this side must also then be opposite a 60-degree angle. And if that's 60, that's 60, this can only be 60. Okay. And there's that. Oh, this is fun. I don't know what you guys, I love this stuff. Some of you might, and some of you might hate it. And that's okay. Different strokes for different folks, man. It's all these wonderful differences that make the world so exciting. All right, come on. Let's continue. Okay. Read these. Pause me for 5 seconds. Ooh, 10 looks fun. And then I'll circle back and do them with you. Okay. Go. All right. Are you done? So we're being told ABC is an equilateral triangle. Find the measure of CAD. And then on the other one, ACD is an equilateral triangle. So not the whole triangle. It's saying, come here, you little monkey. It's saying this one right here is equilateral. Okay. So then you're asked to find missing angle measures. Well, as soon as I see this stuff, as soon as I see this is equilateral, I'm just going 60, 60, and I know, well, I know that's 90. So 90 minus 60, because this is now part of a right triangle here. So 90 minus 60 is going to be 30. So CAD is 30. Does that make sense? If this is a right angle, this is a right angle. Okay. Then finally, what's it want me to find? The measures of ABC, ABC. So it wants this and CDB, this. Okay. So if that's 60, what's this? 60. And then what's this part here? 60. Okay. I don't have any angle measures in here yet. Okay. At this point, there's multiple ways I could go about doing this. All right. What I think I would, well, maybe there's not multiple ways I can do this. Oh yeah, there are multiple ways I could do this. Okay. So one way I could do this is that I could find this angle here by showing that by looking at the larger triangle. Okay. So I've got triangle A, C, D. If that's 60, I have a right angle here, which is 90, then this must be 30. Would you agree? So that's one way that you could do it. And then if this part is 60, this part must also be 30. Oh, opposite angles are equal. Now I know opposite sides are equal. If I have a triangle here, 30 and 30 is 60. Subtract that from 180 and I get 120. Okay? So that's one way to do it. So ABC is 30, CDB is 120. What you also could have done, you have angles on a line right here, and you could have marked that as 120 right away. And then 60 plus this is 90, so you can have your 30 here. 120 and 30 is 150. 180 minus 150 is 30. Okay? Couple different ways to go about it. If I'm having fun, don't judge. Oosh, I'm already at 10 minutes. Good thing I didn't do this all in one day. All right, pause me, have a puzzle party. Come back, we'll do it in 5 seconds. Go. All right. How'd you do? I'm going to start, so if you haven't finished, make sure you do that. Are you ready? So ABC is an equilateral triangle. That's good to know. And PQR is an equilateral triangle. Good to know. I'm going to start there. Okay. For this, I want to find the measure of ADE. Oh, how interesting. Okay. So here's what I'm going to do. So for ADE, and I've got this little triangle down here, I know this is 60. So if this is 60 and this is 90, this is a right triangle. I can do 90 minus 60 and I get 30 right there. Okay. So now I can actually find this missing angle because I have three angles on a line. 30 and 90 is 120. And that whole thing, remember that from last chapter, 180 minus 120, that's going to give me 60. Okay. Another way I could do it. Okay. This is 90. I know this is 60 because it's equilateral. That has to be 30. So then if this is 30 and this whole thing is 60, this must also be 30. And if that's a right angle, that's 90, 30 and 90. So then I can do 9 minus 30 is 60, and I get that measurement there as well. Two totally different ways to go about it. Oh, it's so fun, it's so fun, it's so fun. Okay, this guy here I'm finding PTS, right? Equilateral triangle, and PS equals PT. Boom, boom, boom. PQR is an equilateral triangle. So all I need to know is that 60, and then this and this are equal. Okay, that angle is equal to that. So I'm just going to do 180 because it's a triangle minus 60, 120. Then 120 divided by 2 gives me 60 and 60. Really don't need to do anything down here. I don't think I'd go about it any other way, to be honest. PQR is an equilateral triangle. Wait, what am I trying to find? PTS. Yeah. That's it. Okay, I'm overthinking it. Oh, this is fun. Woo! Let's see. You could pause me and do this, and I'll give you a yes or no when we're done. This looks like it could be fun. So go ahead, have some drawing time if that's what you're supposed to do. Get some grid paper. I'll run through the checklist with my terrible backlighting here in just a moment. All right, which triangles cannot be drawn? Triangle with two sides of equal length and one angle greater than 90. Yeah, you could do an isosceles and obtuse triangle. Okay, triangle with three equal measures, that's going to be an equilateral and acute. A right triangle with three sides of equal length, no. Right triangle with two sides of equal length, yes, it's going to be a right triangle, and it's going to be isosceles because those two sides will be opposite 45 degrees angles. Bleh. Triangle with two sides of equal length and all three angles measuring less than 90. Oh, sure. You can do that. And it's just in a acute. And it could be, and it would be isosceles. Okay. Triangle with all three sides different lengths and two equal angle measures. No, because if you have two equal angles, you have two equal sides. Bleh. And a right triangle with all three sides of different lengths. Yes. And that would just be a right triangle. Okay. Then later on in school life, you'll learn about special right triangles like 30, 60, 90s and so on and so forth. Okay. Cool. Man, this is a lot of math. Okay. Triangle PQR, PR equals PQ. Boop, boop. And the measure of angle P is 30. Write what you know about triangle PQR. You can pause me and do that. All right, you ready? I know it's isosceles. I know it's acute. I know that and that is 150, so each one is 75. And I think that's about it. And this one here, read, work, pause me, do it. What do I know? 43 and 47 is 90, so this must be 90. That's a right triangle. It's right, and it's scalene because all sides are different lengths. Holy cow, I was going to try and finish this all in one day. All right. As always, they're not drawn to scale. Get that dirty protractor out of here. Pause me. We're going to go through this in 5 seconds. I think there's only a few of these problems, so pause and we'll discuss. Okay, triangles are not drawn to scale. Find the unknown angles and classify each one in two ways. So that side and that side are equal. That angle and this angle are equal. This one here is going to be 120. It is obtuse and it is isosceles. Okay, this one here is 27, so this must be 63. It's going to be a right, and it's going to be a scalene triangle. This one here, if that's 60, these two are equal. That's 120 divided evenly. You're going to have 60. 60, you're going to have an acute, and you'll have an equilateral triangle. And then finally, 128 plus 30 is 158, leaving 22 degrees. It's an obtuse triangle, and it's scalene because it's got this obtuse angle. Okay. Oh, last two. Pause me while I go turn on the lights, and then we'll go through this in 5 seconds. All right, you ready, Freddies? In triangle PQR, PR equals QR, and then PRQ, and that are right angles. Find the measures of, and they've got a mark for us, QPR, and the measure of QRS. Okay, well, since this is a right triangle and I have equal sides, okay, I know that this angle up here must be 45, so check. And then this one down here is 45, and now I've got another right triangle, so right angle plus 45 plus 45, and I'm good to go. Okay, so 45 and 45. AB, equals CB. Okay, so that's equal to this whole side here. And just so it makes sense to me, because that one line's confusing me, I mean, those two are equal. So this is 70, and I have an isosceles triangle. Those angles must be equal, right? So 180 minus 70 is 110. And then if I divide that by 2, that means that's 55. This whole thing is 55. If I subtract 32, my missing angle down here is going to be 23, I hope. Cool. That's that. That was a long lesson. Quite the puzzle party. Finish your workbook, take a breather. Don't look at me for a while. I can barely look at myself staring at the same image on the screen, but whatevs. You can do this. It's great. It's just puzzles. Have a good one. See you tomorrow.